Bismillahirrahmanirrahim. In today's lecture we are going to learn how to find the cube roots of unity. Now what are the cube roots? Cube roots means by cube roots of 1 we mean that the number whose cube gives you 1. Now we know that in the set of real numbers the only number whose cube is 1 is 1 itself, and there is no other number whose cube gives you 1. But in the set of complex numbers we can find numbers other than 1 whose cubes gives us unity or 1. By unity here they mean 1. Okay, so in order to find those roots, the technique that we are going to use is now suppose x represents the variable x represents all the cube roots of 1. Now if it is a cube root, then it means that x cube should give you 1. Now we want to find the value of x, because x is here representing all the cube roots of 1, so its values will give us the cube roots of 1 which we are seeking in this topic. X cube is equal to 1. Shifting 1 to the left hand side, we get x cube minus 1 equals to 0. Now applying the formula a cube minus b cube, which is equal to a minus b, a square plus ab plus b square. Okay, using this formula x cube minus 1 will be equal to x minus 1, x square plus x into 1 will be x plus 1 square, which is 1 equals to 0. As we have two factors and their product is equal to 0, so either x minus 1 is equal to 0 or x square plus x plus 1 is equal to 0. Solving this equation, x will have the value of 1, okay, which we already know in the set of real numbers. 1 cube is equal to 1, so 1 cube root is this, and from here we are going to get two roots. Okay, we know that this is a quadratic equation, it will have two roots, it means we will have two more numbers whose cube will give us 1. Let us see and calculate what are these numbers. So taking this equation over here, a is equal to 1, b is equal to 1 and c is equal to 1. Using the quadratic formula, the value of x will be negative b plus minus b square minus 4ac over 2a. Okay, so negative 1 plus minus 1 square minus 4a into c over twice of 1. Now solving this, we are going to get under root, this will be 1 and this will be minus 4. 1 minus 4 will be negative 3. Okay, so it means that x will have these two values. X is equal to minus 1 plus under root 3 plus negative under root 3 by 2, and this can also be let me write it here. This can be written as minus 1 plus minus, if I write this number in iota's form, it will be negative 3 can be written as negative 1 under root 1 under root negative 1 and 3, and we know that this is denoted by iota, so it means it will have iota under root 3 or under root 3 iota over 2. So we have two roots, one is 1 plus iota under root 3 by 2 and the other is minus negative 1 minus iota under root 3 over 2. So these are the two complex numbers whose cube root will give us whose cube will give us 1. So it means that we have got three numbers, one which we already knew, that gives us the cube of 1, and the other two roots that we found from this equation, the values of x from this equation we got the value x is equal to 1, and from this equation gave us two complex numbers whose cube is equal to 1. Now if you take the cube of this number, you can easily verify that their cubes will be equal to 1. Now these are the three cube roots, 1, this and this. Okay, so we have three cube roots of 1. Let me write them here, and now we are going to use their properties. There are few properties which we will learn, and we will use them to solve different questions in the exercise. So it means that the roots of unity are, if I write them in the form of a set, 1, -1 plus iota under root 3 by 2, and -1 minus iota under root 3 over 2. These are the three cube roots of unity. It means that these are the numbers whose cube will always give us 1. Okay, and the first property that you need to remember is that now let me denote this root by omega. Then if we take the square of this root, we get this number. So if I have named them this number omega, then this will be omega square. We can easily prove that. Let me do it for you. If you take the square of this number, you get this number, and if you take the square of this complex number, you get this complex number. So we name them 1 omega and omega square. Okay, 1 omega and omega square. We can easily prove that by taking square of this number. If I take square of this complex cube root, if I take the square of this one by applying the formula a minus b, a is under root 3 iota a square plus b square minus 2 a into b, this will be equal to 4. Iota square is minus 1, and under root 3 square will be 3, so this is going to be -3 plus 1 minus 2 iota under root 3 over 4. -3 plus 1 is -2 minus 2 iota under root 3 over 4. If I take 2 common from this, I will get -1 negative under root 3 iota over 4, and as you may see, you have obtained, this was the third cube root of unity. So it means that if I square this number, we get this number, and similarly is the case over here. If I square this number, we get this number. Okay, so one of them I will call it as omega, and the second one will be called omega square. Okay, omega and omega square. Omega, this is how you pronounce it. So till now we have learned that the first property is that